Hello, everybody. I hope you guys have had a better week now that the weather is getting a little bit warmer. We're going to talk this week about phylogeny and cladistics. And we're going to start with Carl Linnaeus, give you guys a little bit of background into the beginnings of this. And he's kind of known as the father of taxonomy. And taxonomy is just the system of classifying and naming organisms. There's some debate about the validity of taxonomy because it's never 100% accurate because it is based on shared characteristics, and sometimes that doesn't actually indicate a shared evolutionary history, but it is the most used system and one of the best ways to kind of visualize these evolutionary trees. Now, Carl Linnaeus wrote Systema Naturae in 1735, and it was an entire book about classifying organisms based off this idea of a hierarchical classification system. So he was just grouping things together according to their levels and their orders. And he kind of determined these based off of shared traits, but he used a system called binomial nomenclature. This is important because before this, there wasn't a standardized system for naming species. So there wasn't any kind of unified knowledge of it. There was various names for various species depending on who was writing about them, which made things kind of confusing. But Linnaeus took, or I guess I should say, he used Latin to name living organisms based on a species, and he did this by including a genus and a species name. The genus kind of indicates how things are related, whereas a species is obviously a more specific name for a specific species. When he did this, he had some trouble with classifying humans. So he did divide them into different subspecies as Homo sapiens and Homo neanderthalensis. That is still a current debate within anthropology, which we will talk about more later in the semester, but the gist of it is that there is some arguments in the community about whether Neanderthals should be classified as Homo sapiens neanderthalensis or just Homo neanderthalensis. He also labeled apes as Homo troglodytes, but at the time, the only ape species that he knew existed were chimps and orangutans. Now, chimps we still do consider Homo troglodytes. So within this classification, you can see that humans kind of follow the same pattern, starting with kingdom. They're in the kingdom Animalia, the phylum Chordata, the class Mammalia, because we're mammals, the order Primates, the family Hominidae, the subfamily Homininae. That can get kind of confusing, so just be careful when you're reading, be careful when you're writing, because it does make a difference. They are also part of the genus Homo and the species Sapiens. This little chart over here shows you how other ape species are classified. And you see that we share a lot of the same classification until you get to the subfamily and the genus order. Here's a little tidbit over here that mentions that gorillas and chimps and bonobos share about 98% of the same DNA as us. Now, when you're classifying things, it's a way to understand how animals speciate. There's a couple different ways that speciation occurs. It can be through anagenesis, which is an evolutionary transformation in one species over time. It's nonlinear or unilinear, which just means that there's no branching off in this tree. You are only focusing on one species and how it has adapted through time to its environment and other evolutionary forces like genetic drift and mutation and natural selection. But it doesn't result in more species. It's just a change in the same species. There's also cladogenesis, which is what we will be focusing on when we're doing things like cladistics and cladograms, which we will talk about shortly. Cladogenesis is the formation of one or more new species from another over time. So it's going to be multilinear and it's going to have those branches. Now within cladogenesis, you can have occasionally things like adaptive radiation occur, which is where you see a rapid diversification of species with changing environmental conditions. So essentially, there is an availability of new environmental niches that creates ecological spaces. And this could be due to a lack of natural predators, particularly great weather, that leads to a lot of population increase as they find new places to roam because that area is too overpopulated. They start to adapt to those areas. It could be, a high prevalence of food. But these ideal kind of situations lead to big booms in speciation. And this is a special case of cladogenesis because we see a lot of branching. The best example for this, or maybe the most interesting one, I think, is this idea of the planet of the apes. This is just what it's kind of called as a joke and a reference to the movies. Maybe the movies were referencing this. I'm not really sure. But either way, during the Miocene, there was this huge fluorescence in ape species. So conditions just worked out to be really well, and a lot of speciation in apes occurred. Apes start to appear in the record about 23 million years ago, and during this ape fluorescent or planet of the apes period, there were over 100 species of Miocene apes, many of which were also in places that we don't typically think of gray apes being, like North America. Now, that's obviously not still the case. Around today's standards, there are only about 28 species. Now, when you're trying to showcase any kind of cladogenesis, it's helpful to have a way to visualize all of that branching and how traits change over time. And we do this by separating groups of organisms into things called clades. So you're separating these groups based off of the idea that they have evolved from a common ancestor. Cladistics is just the method of classification of animals and plants according to the proportion of shared characteristics that they have in common. It is also assumed within cladistics that the higher number of characteristics that two organisms share, the more recently they were related, that they shared a common ancestor. Now, within cladistics, you can have homologies, and these can be primitive or ancestral, or they can be derived. These primitive traits are going to be features or characteristics shared by groups of species because they are present in a remote common ancestor. For example, eye orbit. All primates have an enclosed eye orbital. They are not the only animals that have this, but the fact that all great apes especially have this enclosed eye orbit means that we can trace it back to a common ancestor. Now you can also have derived traits, and these are going to be features that are shared uniquely between two or more descendant species. For example, large brains. Within primates, especially within the genus Homo, we have significantly larger brains than other primate species, and that kind of sets us apart. Now, it can get a little bit confusing because depending on where you are looking in your cladogram or your little tree there, what is labeled as a primitive or a derived trait changes. So it depends on what you're comparing it to and which groups you're looking at specifically. You can also have things called homoplagies, and this is a trait that is shared by a set of species, but it doesn't come from a common ancestor. So for example, wings. Bats have wings, birds have wings, but we know that they don't share a common ancestor. This happens due to parallel or convergent evolution, essentially this idea of independent evolution. Sometimes, even though species are related in no way, or their common ancestor goes way, way back, all the way to like just the idea that they are both mammals, if it is evolutionarily advantageous, sometimes two species will still end up developing similar traits like wings. Now we're looking at a little example of a cladogram here, and you can see these blank squares with this Y box. Those are going to be your primitive traits. All of these further species going up are going to share this primitive trait. You can also have autapomorphies, and that is going to be a new trait or a derived trait. And you can see here in this X generation that we have this kind of upside down triangle. And you see that B and C are both going to also have that trait. So when you're looking at species B and C over here compared to X, then you could say that B and C share a primitive trait in the form of this upside down triangle. Now, when you're talking about this X species compared to this Y species, this upside down triangle would be a derived trait because it is a new one. Likewise, over here you can see between diagram 1 and diagram 2 that a couple of these are sharing this diamond. Now you can see in here for diagram 1 that this becomes a derived trait for A and B through this X species, whereas in diagram 2, this is an entirely new trait that isn't shared with a common ancestor. So the fact that they share these traits between diagram 1 and diagram 2 would make them homoplagies because it is a parallel evolution, even though there's no shared ancestor between these groups. Whereas with A and B in diagram 2, it's only going to be a homoplagy between this species A and this species B. Now this is the cladogram from your guys' homework. This is the preferred way to write a cladogram, where you are going to put all of your species in a row across the top and then build down from them based off of shared traits and the prevalency of them to create all of your branches and this kind of tree shape. When you're reading your cladogram, be careful. Don't just assume that anything is a derived trait just because it isn't at the bottom of your cladogram which you can assume anything at the very bottom of a cladogram is always going to be a primitive trait for all of the species of your cladogram. Also be sure whenever you are comparing species like Homo sapiens to like Pan, that you are paying attention to where these branches are occurring, because if it asks you what the derived traits of Homo sapiens are compared to Pan, then you're going to want to include everything, all of these traits that Pan doesn't have. So for humans, that's going to be things like the relatively large brain size and symbolic behavior. It's also going to include things like bipedalism and reduced canine dimorphism. Now, if you're looking at or trying to identify the primitive traits that these two species share, it is going to be this catarrhine noses, the 2-1-2-3 dental pattern, and then because we are more concerned, we're comparing humans to Pan, then we're also going to consider these large brains and highly stable wrist joints as a primitive trait. We'll come back to this. Now, whenever you are creating a cladogram, there are some assumptions that you need to keep in mind. One is that you want to list your general characteristics that are important to the species that you're going to base your cladogram around. For each characteristics, you then want to record the different states that it appears in. We will refer back to this table. So that's going to be, you can do this in any way. You could do it as bullet points or just writing it. A lot of people use tables though, because you can see it very clearly. So you want to record how each species shares or shows or doesn't show these characteristics. Tables are really nice because they allow you to see the frequency. And whenever you are ranking character traits as primitive or derived, you really need to be able to see the frequency of those traits. Then you're going to sort your species into clades using derived characteristics or the frequencies of derived characteristics. So moving back to our table here, this is the same one from your guys' homework. You can see that we have species A, B, C, D, and E. So whenever you are creating, let me share. Oh, no, it's not gonna. Okay, there we go. You want to put these in order across the top. You could start it from D and go to A, or you could start from A and go to D, but you need to keep them in alphabetical order, just because it makes it significantly easier to draw your cladogram for your homework assignment. Now, I do recommend starting from A as your long branch, just because A is going to have the most derived traits in this case, and so it's easier to visualize if you connect everything to it, because it will share all of the previous traits as far as primitive traits go. And make sure whenever you are making your cladogram that you clearly label all of your branches with the new traits to show why it's branching off. So if you look, I don't think it'll let me show you both of them at the same time. All right, if we look at this table, then you can see that the only trait that every single one of these species shares is opposable thumbs. So that's going to become our primitive trait. As we move up, you can see that drooping noses are the second most shared. So that will be our next branch. Let me see if I can. Okay. So we'll start with these opposable thumbs, then drooping noses, then having tails or no tails, and then the presence of the os central, which is just a wrist bone. So when we're conducting, or when we're creating our cladogram, at the bottom, we're going to have these opposable thumbs. And then we're going to work our way up depending on the different traits that are shared and the frequencies. So whatever traits are shared the most or most frequently, we want to have here at the bottom, working our way up into traits that are shared the least, that are shared between fewer species. Now you should watch this video about olive baboons and try and answer how they have adapted to the environment. Don't overthink it. Also, kind of keep in mind the typical baboon diet. I think the only other thing that I should mention is your homework. The very last problem for it is going to ask you to create a cladogram for Wichita State University. This confuses a lot of students, which I understand. The best advice I can give you for that is that it's typically easiest to look at it by the way of how many credits are required to be considered each level in college. So that's going to be how many credits you need to have to be considered a freshman. This can be a range, by the way. This could also be the number of credits that you need to have then to be a sophomore, a junior. You could go all the way up to graduate level. You could do it based off of teachers and the differences, the requirements between associate or adjunct versus like tenured professors. A lot of students have done it over different colleges. So the different like large overarching departments and then the majors that are within it. And they've kind of come up with traits to define those versus, based off of like which ones require more writing or more creativity or the jobs that are available within those majors and which ones are kind of shared and which ones are completely different. Some students do it based off of the sports here at WSU, differentiating between them with their branches based off of traits like what kind of ball is used, whether it's round or not, if other utensils are used, such as bats or hockey sticks, or even if you are kicking versus hitting or, whatever the ball. It's really up to you. You guys be creative, come up with whatever, or you can use one of these ideas that I've mentioned. The only thing that you cannot do is base it off of demographics of students or professors. So you can't base it off of gender, sex, race, just really anything like that. But yeah, let me know if you guys have any questions. I will say I am working on getting caught up on grading. It will get better as we move throughout the semester. These first couple labs always take me a really long time, but later on in the semester, a lot of the questions will be more based off of your guys' ideas and how you are kind of making connections to things. So I won't have to grade them with as strict of a rubric, and it doesn't really take me as long. For those of you that haven't gotten quiz 1 back yet, you will probably get that first before any of the other labs 2 or 3. Just because quizzes are always much quicker for me to grade. You might even get lab 3 back before lab 2 because it is also just a shorter assignment that's easier for me to grade quickly. But yeah, if you guys have any questions, as always, let me know. I know a lot of you guys are having a really rough time right now or have been really sick, and I hope you guys start feeling better soon. It's, especially since I am behind on grading right now, I don't really mind if you guys need an extra day or so to turn something in. That's totally fine. At least until I get caught up with grading, I'm not going to penalize stuff that is turned in a few days late. That being said, if it is like a week or more late, and we haven't talked about that previously, it'll still be subject to that, reduction. So just keep communicating. I enjoy hearing from all of you guys, even though so many of you guys are having a rough time right now. I hope this nice weather kind of lifts some spirits. But have a good week, and I will see you guys next time.